this. I want you guys to see me. I want you guys to see the. Oh no, it's getting the whole thing. I can cut it later. So the best way to learn welding is just like go and weld, but like I think like if you don't know anything and you just start doing, then it makes life a lot more difficult. You know, like you should never go to a country that you know zero and try to learn a language there. Like you should at least learn a little bit so you can at least not be afraid of doing it, you know, and then you can learn stuff. So the way that we're going to do this is that like we're going to have again like we're going to have this lecture and I'm going to post this class so you guys can come back and for sure it's not going to be 100% of welding, but it's like I said, like it's just the basics for the layout and for settings and for how you're going to interact with the equipment so you can do like a weld. And our job is not to make you a welder, but to make it like a proficient, so you can do the work that you need to do until you graduate from here. So if you see the senior design projects, all of them require some kind of welding, because if we're going to do anything that's interesting, so we have like a snow ATV, we have the bike, you end up having to weld, you know. So that's kind of the reason why we have welding this session in this class. So one thing that like usually people don't understand is like even though you're going to be using the welding helmet, you still need to use the safety glasses under it. If you don't use the safety glasses under it, some of the radiation that's generated by the flashes is gonna start like hurting your eye. And the things like the eye doesn't have any pain sensors on it. So like if you look into the sun, and like it's not they're gonna have like so like, you know, imagine there's a solar eclipse and then people look straight to the sun. You can still see the sun, but like at the same time you're hurting your eye, but you can feel that it's hurting just because the eye don't have like a nerve that's gonna tell pain. So like if you don't use the safety glasses under your helmet, you're gonna feel like your eyes are all like with like a sand on it, because like it's just like getting hurt in some way. And the more prolonged non-use of the safety glasses is going to harm it more. So for example, I bought these glasses as being safety glasses, so technically they should have the same rating, like an OSHA rating as a safety glass. So I was welding with it, and guess what? For the rest, I welded for like 5-10 minutes. For the rest of the day, my eyes were like all sore. And then now I know that I have to wear like another glass over these glasses, because this doesn't have the right protection as it should. So we're going to use welding gloves. We're going to use the welding jacket. We're trying not to use fabric shoes. So like when you have this mesh on top, there's a chance that the sparks are going to just fall there and just like kind of melt it. So like we're going to try to use some shoe that's like it's like what they call like a hard top shoe or work boots or work shoes or whatever they can call it, but it's just something that's like a more like hard on top. And the same with pants. If you use like pants like dress pants, then those are like a thinner, so like those are there's a higher chance that those are going to damage. So so I would use like jeans or some like a thicker material. So we might need some head and neck protection. Maybe not here for this class, but like you might need it because like as you're gonna see, welding also has a lot related to like how you're gonna position yourself so you can do the weld. So for example, imagine you're gonna be like this, like and all the sparks are gonna fly over your helmet. Then you're gonna get hit on your neck and it might not be comfortable. So like that's why like you see they use like something on their head and goes down here, and then they put the helmet on top, and then the motorbikes like start using those too. So like and another one, watch for the material that are welding. So for example, galvanized material, if you say is it weldable, for sure you can fuse the material and make two pieces become one. Is it safe? No, because a lot of all these plated materials, they have like whenever you weld, you get into a point that like whatever coating you have there is gonna become a fume, and that fume sometimes is toxic. So like we're only gonna weld pieces that are clean, like clean pieces of steel. We're not gonna try to weld a zinc plated bolt. We just go and get like a bolt that's not zinc plated, you know, or like any kind of other material that. So we have to understand what material we're welding before we even do anything. And the last thing, like we're going to be using welding gloves, right? But the weld itself, it's a lot hotter than the glove can handle. If you weld a piece and you just grab it, you might burn your hand. So you're gonna see that like the way that we're gonna do it, we're gonna weld a handle on it, and then we're always gonna use the handle to move our piece. So we know that the handle wasn't welded, like because it's just like the first tacks in the first weld, and we're gonna put our name on it. So we know that the handle is always gonna be cold. And usually, and I think we're gonna talk about it later, but like the one thing that like usually people don't think about when they're welding is the heat management. The metal cannot take that much heat without deforming. So for example, in the beginning, as we're gonna practice, we're gonna put like a bead on one side, we're gonna turn it around, put a bead on the other side, and then we're gonna quench in water just so like it kind of cools off. Because like if we just keep welding on and welding and welding and welding, the piece that we're welding is already gonna be very hot. It is not gonna be the same as you welding on the piece that's like, you know, I just grabbed the two pieces that I'm gonna weld. That weld is different than like I have two pieces that are already very hot and I try to weld, right? So that's how it's gonna be in the beginning. We're gonna have like two people working, and then like you're gonna put your two beads, we're gonna quench in water, but we're just gonna do just enough not to be wet, because like the heat is already gonna, like as soon as you pull out, the heat's already gonna make all the water evaporate. So that's how we're gonna do it. So these I pulled out from our I don't know if this shows on the camera shows on that. So this is what I pulled out from the manual of our welder. So as I said, gases and fumes might be harmful to your health. And again, like we're also going to have our hood on all the time, right? So always remember to turn on the hood. Sparks and hot workpiece. The arc may cause eye inflammation. So that's why I say like if you keep welding without those like safety glasses under it, you're gonna get what they call like a welder's eye. So you're gonna have like an inflammation on your eye. So there is a gas cylinder on the back. So tipping the gas cylinder, misuse of gas cylinder. So inside of the machine, as I'm going to show, that we're going to be doing MIG welding. So there's a spool inside that turns. So when you're replacing those parts, that's an electric motor there. So you were required to hit the trigger so it spools out. So it says be careful with moving parts. They say the wire that's coming out of the spool gun, so the wire that we're going to use to weld, that's pretty sharp. So there's a chance that those are going to go through, for example, your hand or somebody's hand or your. So we have to be careful with the trigger. And if you read the manual, it says never look on the tip of your gun, because sometimes imagine that you are trying to get a wire coming out, so you're pushing the trigger, and then at some point you get stuck in there, and then you go like this and you keep pushing it. If it comes out, then you're blind. So never look on we're gonna find ways to actually pull it out, but never look into the gun, right? Any gun. Okay. All right, so welding is pretty much you just fuse two pieces of metal, right? Or you can be two pieces of anything. It can be so for one of the groups, we're making a belt, so we have to weld the urethane plastic that they have. So to make that, either you have to heat them up to the point that you can put them together, and now now they become one thing. But it can be through a friction. It can be through anything. That but how does friction work? You're just gonna move it. You're gonna just rub one on the other one so fast, or with so much friction, that they're gonna get so hot, and when you stop, they're just one piece. So there's many different ways of welding, and we're just gonna cover one of them, right? So when we think about welding, we have the paired material. That's the ones that the two pieces that we're gonna weld together. And whatever is the consumable material, that's the one that we're gonna put in here, and this is gonna become part of those two. So as soon as we weld, this piece now, it's part of this two, and then now this is one piece. Whatever is the amount of material that goes in and makes the bond in here, it makes the bond there. This one is the material that penetrated. So so that's why you hear a lot. They say it doesn't matter how much material there is here on top. It matters how the penetration was. What's the bond that you have there, right? So for example, this is a weld. I don't know if you can see here. So now this was fused with this piece. This is a T joint. So this is fused right here, and this is fused right there. So if you're gonna shear it or break it, you're gonna have to go along these. So either you have to break like this, or to break like that, or to break in the middle. See, just because the bond here was even, and if the shear would be along this axis, because of how you actually place your joint, then the root, which is this piece, would actually have also an impact. So the penetration that we get is a variable of like how much heat and how much material you're feeding, right? Sometimes you want these to go all the way there. So this, imagine that this is actually, so these two materials are not the same, right? It's a T-joint. As these two materials are not the same, and I don't put a weld bead here, sometimes I want to make these to actually come and make a bond all the way to the side. So we'd have to change settings just so like that this would actually extend further in. So there's more penetration. But again, if we have more heat to get more penetration, then we have more heat that can actually warp our material or deform our material in general. All right, so this is actually coming back to the same idea. So I pulled out this something that says like a weld evaluation. So we want to have the weld being even. And the bead here cannot be I don't know like exactly how this is called, but like imagine you have a bead that's like this. Whenever you have something like this, this is going to be a weak point just because of construction. This means that the bond here is not good. And that's exactly where it's going to break it. So we want it to be curved. It doesn't have to be like this. It can be, but it cannot be like this. Because this is going to be the weak point. Whatever is the indent in there. So see, if you were to shear, then it's going to actually have a different impact than a good weld. That whatever size strength is actually, so how the weld bead is actually going to help the most on your material fusion there. So now let's go to joint types. I was just talking to a student there, and he was, I was building this, and it was supposed to be this size, and it wasn't at the end, because a lot that goes into the welding comes even before start welding, like how you're gonna set up your stuff, so your weld, if done well, is gonna work. If I start with material that like as soon as even if I do a good, there's a chance that like I'm gonna lay out my material, and even though my weld was perfect, the final product is bad. Why? Because my layout started bad. So we're gonna look a little bit into layout. So usually, so these are the 5 most common welding types or welding joints. So we have a butt joint, a left joint, a T joint, an outside corner joint, or a corner joint. Yeah, outside corner joint and an edge joint. So we're gonna actually look into each of them. Butt joint, it's like imagine you want to weld 2 pieces to make like so I have a piece of metal like this, and I want to extend it. I can just weld another one like this, right? So if I actually cut in a V shape or a U shape into my pieces that I'm gonna weld, I can start filling in from the bottom. And then now there's gonna be bond all the way. If I have the 2 pieces just being straight up flat, your bead is going to be like this. But then, do you want this bump there? Maybe not, otherwise it's not going to fit. And then what? You're going to grind it. And that's all that you have. Right? Oh, but what if I spend more time here? Then there's a chance that this guy is going to work. You know, so that's why they make this V groove or U groove, so you can actually fill up it all the way. But as I was talking to the students, saying, you know, the welding has two purposes: hold the material, but keep the shape that you want, and it has the strength that you want. Oh, I just want to tackle these two pieces just to hold for a little bit, and then I don't care. That's fine, you know. But how much it's gonna hold, then that's the question, you know. So if you go to a manufacturing environment, there's gonna be exactly how you have to do these things. So all the numbers on the engineering side, all that the engineers calculate that you guys calculated, is not gonna be correct. You say this should hold this amount of so many pounds, and then the guy fails to use the proper method, then maybe you're not gonna have that same thing, you know. So T-joints, that's the same case. I can put a bit in on that side, and maybe I can't put a bit here because whatever is gonna fit here is gonna be a square piece. So then that's when you have to actually start working on what groove you're gonna get there. So I can weld here, and even though I'm gonna grind down to make the next piece fit here, I'm gonna still have a good bond in there and sufficient material to hold it to whatever strength you wanna. So as I always like to show things when they don't work. So my idea is we're gonna do a bunch of welds, we're gonna practice welding, but at the same time, we're gonna make some welds that we think that are good, some welds that we think that are bad. We're gonna make sure we make a weld that's horrible, and we're gonna put everything on the UTM and break it and see how much it's gonna hold, right? Corner joint. So why do you think a guy would place it like this and weld it from the side, from the back, instead of placing like this? Again, imagine you want to fit something in here. I don't want to fill this up with weld with a material deposit there, and then I have to grind, and then the only thing that I get is the penetration. So if you do this and weld on the outside, there's more material and more penetration on both sides. So that's a corner joint. That's a lap joint. A lap is you pretty much put one on top of the other one, and it just weld right on the side, which I think that's kind of the easiest to do. In an edge joint, as you're gonna see, it's not so easy to weld materials that are so thin. Why? Because the heat is gonna actually burn through the material. So you're gonna have holes, as soon as you touch it, the metal you're trying to weld is just gonna melt. So it's common to use weld joints. Imagine you have a thin piece of material, and you want to weld two pieces like this, just like a butt joint. But then if I weld like this, I have a burn through all the time. So one thing that you might want to do is you put the two materials like this, and you do a mat joint. And then you bend it. So see, instead of a T here, I'm gonna do a weld joint, and now I don't put anything in there, or I put another one in there. It's just a different way of doing it. That might be because we're just like a welding something that's just so thin, right? So there's, as I said at the beginning, hundreds of different kinds of welds, right? We have a machine that's called a multi-process machine. So our machine can do 4 different types of weld. And that's pretty much the ones that we're going to cover here, like when we talk about it. But like when we go there, we're only going to be doing the MIG welding, right? So we have 2 welding technologies here that says gas. That means at the same time that they're doing the weld, let's see. So at the same time that they're doing the weld, you have a shield gas. So you make sure that the melted steel doesn't oxidize with the oxygen. So the oxygen doesn't impact on your weld. So that's why you have the shielding gas. But then what happens with the other ones? The ones that don't have shielding gas. They already have something embedded on the material that are depositing. For example, the stick weld. If we look at the stick itself, so like that's the one that you have like a clamp, and the clamp is holding a stick, and then this is the material that are going to deposit. If you look at this piece, it's like this. So this is the outside. So as soon as you touch, so this is the weld, right? This is the material, and this material here on the side is something to protect the weld. So it's already embedded there. So imagine we're in here, there's no wind, right? We're inside, there's no wind. It's easier to use one that has a gas, right? Because if I go outside, there's wind. How is the wind going to impact like my gas coming out of my gun, right? At the same time, I'm going to weld outside. I have to bring my welder with me. Now I have to bring my welder and my C25 cylinder, you know. So that's why like you'd actually go and use different processes if depending on like what the situation that you're welding on. All right, so now we're gonna try to lean more into like a MIG welding, just because that's what we're gonna be doing. So imagine you have the MIG gun, right? I'm gonna place a bit of weld right here. I can do it in 2 ways, right? I can go that way and start depositing, or I can go in this direction, right? So there's two different ways. So that's what we call pulling the gun when you're going in that movement direction, or when you're going pushing the gun. So we're going towards the material. And then each of the methods is going to deliver a different weld bead. And sometimes you want to use one, sometimes you want to use the other one. You're going to be better at one than the other one. So like a, so let's say pulling the gun. Pulling the gun is easier because you're just like making your hand movement like this, right? You kind of don't have to control the distance to your weld because you're just pulling and you're squeezing the trigger. So the wire is actually filling up that gap that we're creating, right? So technically it's easier. You're pulling the gun. So the metal here is actually not as hot as the metal there. See? Because the heat's going in that direction. So you're welding something that's cooler. This is better for speed because you can just go instead of going. And then you're gonna try to change the distance to your workpiece. The one thing that I think that it makes the most impact for myself is that it's a lot easier to see where you're going, because we're gonna be using the automatic darkening helmet, so you can see things. As soon as a spark comes out, it's gonna darken, but you don't actually tack one side, tack the other side, and keep adding tacks all over the place. You know, it's more like you're gonna be carrying over with a weld. So like as soon as it darkens for the first time, it's gonna be pretty much dark, and you have to know how you're gonna move. If you're pushing the gun, the spark here is gonna actually make it easier to see where you're going. So when I'm pushing the gun, I can see better than when I'm pulling the gun. And you guys are gonna see what I mean when. So it's easier to see. There's better gas coverage because the gas is actually going that way. It's easier to weave because I think it's easier to see. And here, see like how the heat is going that way. So the material here is going to be like slightly hotter. So I'm going to actually warm the material, then I'm going to place the bead in a little bit as I move. So we're going to try again. We're going to try both. Can you delete this one? All right. So now let's go into, we just talking about weaving. Weaving means I'm not gonna just like lay one bead like this. Remember that when we're talking about, we actually want to make, so imagine you just come and you pull the gun and you just like leave one bead there. This is what we're going to do. Is that strong enough? Maybe not. So maybe you want to increase penetration. Maybe you want to increase the surface area. So that's when we're going to talk about weaving or making your bead bigger. So there's going to be different methods of how, as I said, it's all about planning. You're going to say, I'm going to do it like this. and I'm gonna do it like this all the way to the bottom. So it's like I don't have like imagine that you have like your weld there. So you have weld here, and then this is actually worse, and then this is better, and this, now if you have to break, you're gonna break where it's well. Like you want to make it constant. So you're gonna start the B, and you're gonna say, I'm gonna follow the cursive E. So the cursive E all along. So you're gonna start here with your gun, and you're gonna go as long as you have to go all the way there. One difference between when you're using a gun with a spool. So for example, there's a spool inside of the machine with all that filament or all that metal that are going to use to weld. I can come in weld a pretty long weld all in one shot, right? What do I have to do when I go back to a stick weld? This is how long the stick is. I have to do a long weld. You have to use one stick. Stop. Get another stick and continue. And then you're going to have to do what they call catch up. Your weld's going to end here. You're going to have to find a way to actually tie a knot with the previous weld so you can continue the weld. So that's like a one advantage of like the MIG or the flux core welding, just because you have a spool in there, and the spool is, I don't know, it's a 10-pound spool that's in there. So you can weld a lot until you actually run out. But again, when we do this, any kind of weaving, you're going to deposit more material. You're going to have better, let's say, you're going to have a better penetration. But again, we're going to say it again. We have a lot of heat. There's a lot of the heat. So we are going to have to think how much the heat is going to impact on my final piece. How much heat can I have on this piece? Because like at some point, if you have a lot of heat on something that's thin, it's going to warp, or it's going to deform, or it's going to punch holes. So we're going to have to think about the heat. All right. So we're going to be doing MIG welding, as we said. So we're going to have a gun. It's going to have a solid wire coming out. That means there's either solid wire or flux core wire, but like we're not going to be running flux core. And we're going to have to use the welding gas. The welding gas that we use for MIG is the C25, so it's 75% argon and 25% carbon dioxide. So the gas is going to shield, so the weld can be not impacted with the oxygen from the air. And see, I drew out this picture, but see like a heat affected zone. Because like we're going to make sure we actually do something that goes wrong, and we can see the impact of heat. And the depth of penetration is a variable of time. Time means how much time I'm going to be in that same spot, and how much heat I'm going to generate, and then how much voltage I'm going to use on my machine, like all my setup, and what's the current. But also the voltage and the current and the heat has also, in this case, a variable, it's also a variable of the wire feed, how much wire I'm feeding, because that's how much welding I'm doing. So it's like how much wire I'm putting out and how fast I'm moving, and the voltage. So we said that we're going to have the gas protecting your weld, right? So we have the nozzle right here. The solid wire comes from the center of the nozzle, and there's a, like, from the center of what they call the contact tip, that's this one. The nozzle is this one, and the gas comes around it. So there is a max distance that you want to have your nozzle from your weld or from your workpiece. So your gas works. Your gas chute works. If you are too far from it, then you're going to start having problems on your weld, right? If we're too far, then what happens? If I increase my stick out, or that's how much wire I have sticking out of my nozzle. I'm actually going to have to increase my voltage. So like, imagine I'm coming out further. This arc length is going to change. So for me to make this arc, so let's start from the very beginning. How does this work? You have some voltage applied between these 2 points. So between the wire here and this, and as soon as you get close enough, there's an arc voltage, just like an arc that you actually can warm up yourself and like zap somebody. But this arc is gonna get it's so hot that's gonna make this piece melt, that piece melt, and this is gonna actually stick to that one. So that's the welding, so that's the proper the welding itself. So if you pull out, you're not protecting that much. So the arc length is going to change. Your machine is going to change the voltage on it to make sure that happens. And then if my current's going to decrease, just because it's going to be so difficult to actually breach the air gap. And then I'm going to decrease my penetration. And some other bad things are going to happen. So how are we going to make sure we're going to do something bad, you know? So I put a video here that you guys can watch. So this guy is welding, and that's pretty much what we're going to do. We're going to turn off the gas and let it run without gas. Can you weld without gas? Yes, there is the gas here is not to protect us, it's to protect the weld. What's the impact of running with no gas? Increase the voltage, decrease the current, and the penetration is worse. So your weld is going to be much worse. You're not going to be able to leave a bead like this. It's going to be more like this. So you're going to see it's going to be like more like a bunch of blobs together. And there's going to be what they call splatter. A bunch of these welds are just going to jump. It's going to like a stick all over the place. Just because the air is actually trying to mess up with your weld. It's not just allowing the heat and the two like melted metals just to actually become one. It's just going to create all this mess. And we're going to make sure we do that just so we see what's a good one and what's a bad one. All right. So as I said, how does the machine work? We have a ground clamp. As soon as we put our nozzle, our gun here, we press the trigger. We apply when we press the trigger, we apply voltage between these 2 points, between my wire coming out and my ground. If I get my gun right now, I don't push the trigger, and I touch my workpiece, it does nothing. There's no voltage there. The voltage turns on as soon as I press the trigger. As soon as I press the trigger, the voltage turns on. The filament or the wire starts coming out, and the gas starts coming out at the same time. So we're gonna have the C25 cylinder connected there. Before we start, we're gonna turn on the valve. So we open the valve, and then we can weld. There's a chance they're gonna start welding and say like, "Oh, my weld looks like it's so bad," and then, "Oh, I forgot to open my cylinder," you know, or I ran out of gas. Now can I weld? So like the guy here on that video, he's like, you know, does this weld work? It's gonna hold. Is it a good weld? No. It's not as strong as a weld, you know, but it's gonna hold two pieces together for a while as I, you know, should I use that? Maybe not. So this is pretty much the basic setup there. And this is how our machine looks like. So we're gonna set it up to big. So there's a button here that we can choose whatever process we're gonna use. There's the 2T or 4T. That means how many variables I'm gonna be playing with. So here I'm playing with two variables, 2T. When I move this knob and I'm on this spin, these two things are going to change kind of together. There's a relation between those two. So this is the voltage, and this is the millimeters per minute that my wire is coming out. So the only variables that we have that we can see here is voltage and wire feed. But I'm not really interested in wire feed, right? I'm interested in current. But the current's going to be impacted by this. It's going to be impacted by the distance. It's going to be impacted by some other things that you can change here. You don't go and, like for me, you don't go and set, I want 120 amps. It's not going to be like that. It's going to be more like TIG. TIG, you go like and say, this is the current that I want, and this is the voltage that I want. It doesn't matter the rest. This one, no, it's going to be, and as you weld, so this is the screen that you have when you're not welding. When you hold the gun and you're not pushing the trigger, this is what you see. As soon as you push the trigger and you start welding, this value, so see this light here, it's going to move to A, which is the amps, and then you're going to be able to see how many amps you're using to weld. And that's going to change if you're closer, and if you pull out, the feed is the same. The current and the voltage are going to mess up, and then that's when you're going to start like having the splatter, and you're going to impact your depth of penetration. So that's why you want to make it so it's as constant as possible. But the problem with making it constant is it's not like even on the lathe it was difficult to keep moving the drives like by hand, or even on the mill you just go like moving the machine. So you're gonna pretty much have to get in a position that you're comfortable and your movement is gonna happen. So sometimes you're gonna hold the trigger, you're gonna hold the cord for the trigger, and you're gonna be in a certain position. Because sometimes you're gonna go up, sometimes you're gonna go to the side, sometimes you wanna move to the other side. So your body positioning, your hand, how your hand is gonna lay on the piece. Another one like a, why is it like a pulling the gun easier? I can just lay my hand on my workpiece, and that's stable enough so I can just like drag my hand on the top of the material, you know? If this material here is not bumpy, I can just put my hand here, hold my gun, and go like this. So I use my workpiece to actually help me stay steady. But if I try to do this, you're actually rubbing your hand on the workpiece, so you're kind of like I try to lift a little bit, so that it's actually more difficult to stay steady. So that's why like a lot of the positioning and how you're gonna do. So that's why I said like sometimes you're like, you know, I'm gonna do this, and then you put yourself in a position. Then now all those sparks are gonna go where you were having sparks before, you know. So like I was trying to weld like this, and then they were all flying over my head, and I was like, oh crap, I have to have something on my neck, you know. So like that's gonna be based on positioning, on actually body positioning. So like as I said, like the class is not to make you a welder. So we're gonna do all the practices. It's like I think this is actually made so we can do it in a good way and have a good result for welding for all the projects that we're gonna do throughout the program. And we can do it safe, and we're not afraid of it. As soon as we're not afraid of it, we can just come and do more. We have students that maybe they're not as comfortable, so like, you know, you can weld like because you do a better job. Like you were excited about welding, you're not gonna be afraid of it, you're gonna be doing more for every single project, you know? All right, so this is inside of the machine when you open the machine on the side. So this is where we load our spool of wire. And then when we press the trigger, there's a motor here that's just gonna pull this wire and just feed it through the gun all the way to your nozzle, right? So that's the spool gun. When I press the trigger, the wire coming into and there's the contact tip. And you see this little black dot here? There's holes there, so the gas comes from the side, comes out from those holes, and goes around your weld through the nozzle. Right? So if you decide, like we also have so this machine is also capable to do flux core welding. So flux core welding, the flux is going to help to protect the weld, right? So we're not going to be using the gas. Can I take out this nozzle? Technically, yes. Will we take out the nozzle? No. Why we're not going to take out the nozzle? Because if you don't have the nozzle and you touch the contact tip on your workpiece, it's welded there. So we're always going to use nozzle, even if you guys change the process and you go into a flux core. Okay. And here, just for you guys to, if you guys want to read through, these are the instructions of how you set things up that are on the manual. I'm going to make sure I make the manual available and easy for you guys to find in the class. And then like on the manual, just go through and you have an explanation of every single thing of that you can do with the machine. But usually I would rather go on YouTube and watch people doing it or come and do it myself rather than just be the manual, because the manual doesn't say everything. Like sometimes like you see somebody doing, oh, this is what that means. So, but I try to make sure I put all the details that they have it on the manual for MIG welding right here on the presentation, just so you can just open the presentation and the information is already there. Good. So, as I said, like we're gonna split the group into the class into 2 groups, and then we're gonna be we're gonna have a plan, like a project that we're gonna try to do all the different weld joints. So just so you guys have an idea, we're gonna start, as I said, welding a handle on our workpiece. Why? Because then we can always use our handle to move it around to actually quench. So we're gonna tack our welds there. Put a bit there so this holds. It's gonna be our first one, so most likely it's not gonna be our best one. Then we're gonna put our initials here, right? And then we know which workpiece is for which person. And then we're gonna come in, place a bit there, turn it around, and place a bit on that side. So you see that this side, as soon as I place this bit, this side is hot. When I turn it around, this side is here. So I can place that bit right there, and it's not going to be hot. I place a bit on each side, quench the water, put it back in, put another in. Until we get comfortable with it. Now, we were pulling the gun. Now what about pushing the gun? Let's do some pushing the guns. Are we comfortable? Oh, we started like doing a better job. Okay. Now, what if we put like a butt joint? What about we put a lap joint? What if we put a T joint? You know, and that's how we're gonna progress and have all the work done. So this class now, we're gonna have, I think we have the 2 sophomores, 3. So right now, and Louis, so we're 6. So most likely, and the professors and other people that want to join, but like we have like 3 students in each group. Because in the past, what we did for this class, like we would have 3 groups, and they would go like one group would be doing the lathe, one the mill, and one who would be doing the welding. And the rotation that we did, like for this class, that was just like the lathe and the the mill. We had also welding, so like we had 3 groups rotating. But I think like with less people, we're gonna have the same amount of time. Just because we have less people, we don't have like 4, 5 in each group, right? But we're gonna try, as I said, instead of doing all the different technologies, I wanted to do, okay, what about, so this material that we're gonna be using is gonna be, let's say, 0.2 inches. Okay. What if we use 0.1 inch? I'm very sure why. Because of the heat. How do I change the heat? I can change the settings. Let's change the settings. Oh, I can change the speed. Let's change the speed. Because like then later in the future, you saw with your own eyes that oh you chose that material, you know, you should have chose the other one. You know, so like all those things, because you've done it, you have like you remember and you actually go and learn more. You know what happened. You know, so or even like if you come and try to weld like 5 years from now, you're gonna remember. You know, there was something related to like the thickness of the material. So then you can go back and think more about it. If I just come and tell you about how thick it should be, I don't think you're going to remember. If you've done it and put you and a bunch of big hole there, it's going to be recorded on your mind. You know, wow, this is bunch of holes. It's very difficult. You know, or like how clean should the weld lines be? Oh, I don't care. Let's just weld. Oh no, but like I remember that when I weld, the joint wasn't clean, and then now is this what I get, you know. So I want you guys to really do and see, and we can grab the material. Maybe like most likely I'm not gonna have you guys going with me to the UTM, so I can so we can test it, just because we don't have that much time left, and I want to get you guys to be exposed as much to the doing instead of testing it on the UTM. But I want to show you guys what's the impact of having a bad weld, a good weld. We're going to vote like whose weld is the best one here. Okay, see? This is stronger, this, you know, not to put on the spot, but like I can go and buy a piece welded and it's going to be super strong. But it's not something that we can do, you know, we're not professional welders, you know. But like, okay, I welded this bead here. How good is it? Is it good enough for me to use on my third bike? You know, maybe it is, maybe not. Like, let's test and see the numbers. Good. So Thursday, weather permitting, we're gonna have one group welding, and the other group, I don't know if we're gonna try to come up with something for them to do. What do you think, Jericho?
Cool. Yeah, we'll just have to watch. I don't think we got anything to do.
Okay. And I haven't had any quizzes for you guys. So most likely what I'm gonna do is like I'm gonna create some quizzes so people that are not in the class, they can do some tests and like now all this class that we had today, I'm gonna post the video and I'm gonna post the presentation, and then we're gonna have a quiz about it. And then most likely I'm gonna load some of the lectures that we've done in the past, because like we just so like we make sure you guys understand the main concepts we have throughout the class, right? So whoever is not doing the welding, we just like we just have them like work on something else. So maybe we can do like are you guys gonna be here Thursday? No, but like if they're going back home today, then for sure they're not, you know. You'll be here? You might not be here? Okay. Okay. So yeah. So you have preference not to be like, as we're here today, you have preference on not being here on Thursday. So like not being on the Thursday group. So I'm gonna choose one of the other students to actually go into the
Sure.
Oh, map at home? Okay. Okay. Yeah. So I'm gonna just post on Canvas who's gonna be here for Thursday, or who has to be here for Thursday. Cool. All right. Thank you. Thanks.
Did you talk about pulling the senior? Did you say you want to put this vacant right now?
Yeah. So like they're making Yeah, snow ATV.